Hello everyone and welcome back to another episode. In this one we will talk about game loops and why we need them and how we use them. And without further ado, let's get into the episode right away. But before we start coding, there is one thing we need to fix, and if we run the game, there's nothing, there's just a white background, but as soon as we resize the window, we're calling a function called repaint, which we will get into in this episode. But as you start, there is nothing, and we can fix that quickly. Just move this set visible to the very bottom. The correct order should have set visible at the very end of all these rules we set up and sizes and so on. So it should be at the bottom. That was a miss from me, and then we run it. And now we can see it from the very beginning. Perfect. So why do we need a game loop anyway? Well, there's a few reasons. The most important one is to make sure that the game runs consistently in the same speed. Not only on my computer, but on your computer as well, no matter the hardware setup, programs installed, etc. So if we don't have any way of controlling that, it's not going to be a very pleasant experience. And there's also to handle inputs, as well as to be able to put the game loop in a separate thread, the game thread as we will be calling it. And I will get into what a thread is in a little bit later in this episode. But for now, let's just go into the game screen class and make the most simplest game loop we can do in this setup. And to do that, all we need to do is to type one thing, which is repaint. And what repaint is, it tells the window to repaint itself, so it comes in here and does all of this over and over until you close the window, because this is an infinite loop. There is no break, no pause, nothing like that. So it will go forever. So if you run it, we should have flashing images everywhere, which we have. And we can check the speed. It will be different on my side as well as your side. First off, we need to make a private long variable, and we will call it last time. And long are just a very big whole number like integer, but can store much larger numbers. And we will check in here if system dot, we will use nanotime. No, we will not. We will check current time millis minus last time is more or equal to 1, which will 1000. That will be, we're checking if it's more or equal to 1 second. So this will be called every second. And if it is, we will say system.println system.out print line, and we will say FPS equals whatever it is, which we need to figure out. We also need, of course, we need something to store the tick. I'm gonna say int frames, and we will plus boom, and in here we will go plus frames. We will say what the frame is, then we will say frames equals 0, resetting it, and we will also reset last time equals current time millis. So every time a second have passed, it will print out the frames per that second, and it will reset it. So we should get some sort of frames per second counter right now. Let's see. First one is always fucked up, and then we get 830, 890, 940, 55, 60. So we get about 950 frames per second. And if I resize the window to a much smaller one, we should have much higher frames per second, and we do. And I don't think this matters if I make it much bigger. Come on, work. There we go. I make it, oh, if I make it much bigger, it shouldn't matter too much, but it does. So this is obviously not consistent. Sometimes it's 1500 frames per second and sometimes it's 460. And if we had an update that every update the player moves 1 frame, then 1 second he would move 475 steps, and another one he would move 1500 steps. So that's a very bad game loop, but it's a game loop though. But we can make it better. What if we want to run the game at a stable 60 frames per second? How do we do that? Well, that we can do easily. But before we move forward, we need to clean up a little bit. So private void call FPS. Because this is a little bit too messy in the paint component method. So, and then we just call FPS. And it should work as before. It does. To get a stable 60 frames per second, we need to add 2 more variables. And one of them will be a double and the other one will be a long. So double time per frame, which will be the duration for each frame to be displayed. And the second one will be a long, and it will be the last time we showed the previous or the current frame. Private long last frame. You can name them as you see fit, but these are the best names I can come up with. And to calculate how long each frame will be visible, and since we're running at 60 frames per second, we need to divide a second by 60, but we need to use nanoseconds for precisions. So we will use 1, 2, 3, 1, 2, 3, 1, 2, 3. A billion, which is 1 second is a billion nanoseconds, which is 9 zeros. We're gonna put 0.0 for making sure we get a precision of double precision. There we go. Now we have the time each frame will be visible, which is a second divided by 60, because this is a second, but in just making sure actually, yeah, but in nanoseconds. And down here we will make an if statement. If system dot nanos time, which is nanoseconds, minus last time we viewed frame, or last frame it's called, right? Last frame. Yeah, last frame is more or equal to time per frame. We go in here, else we do nothing. We do a repaint, but before we do repaint, we also need to last frame equals system.nano time. So this should work, but it won't, but we will get to it, why not? So we check if the current time we have been displaying this frame for more or equal than each frame should be displayed. And if that's the case, we update again and show a new frame and also save down the last frame for this time. And if you run it now, it won't work, but I will explain why. It still updates if we change the size, which is good, but remember, it only calls the paint component method if the repaint. So it check here the first time, no, it's not true, so it's false, so it goes in here and does nothing, then we call the FPS and done. It never gets called again. So we need to remove this and go into the game class and add a little bit of code. So we make a new private void loop game. We can call it whatever, but loop game. We will make we will place that there, and we also need to import this one. We also need this one, of course. And we need the variables. Whoops. We need the variables, and we place them there. Let's see, everything works fine, And we don't have any more here left. Nope, it works fine. Then we go in here and we say game.loop game. That should work. That looks correct, yes. But it will only run this once because this is not in a loop yet. So we will make a loop. We make a very simple, hold on, forever or infinite loop as they are called, because there is no way of exiting it. So while it's true, it runs this. And I think this will work. Maybe we need to make it so it's called game screen.repaint. But we'll see, we'll see. Let's run this. And it works. Perfect. And we got 60 FPS. Just as we wanted. In a game loop, there's usually two parts. One for controlling the rendering and the other one for controlling the updates. So far, we got the rendering working at a somewhat stable 60 frames per second. It may vary above or below 1 frame, but that's acceptable for now with this very simple loop. It will get better once we use the threads. So, how about the updates? What's in that method? Everything that handles the logic of the game, such as movements, checking for events, or checking for collisions, etc. The update method is far more important to keep at a stable, constant rate. If this varies, the game speed will be different at different time, which is not very good. If the FPS drops for a second, we get a little bit of lag, but that's it. The game still runs at the same speed behind the scenes. So let's add an update part to this loop, and let's keep the update at a different speed than the frames per second. So we will change the frames per second to 120 frames per second, and we can change or set the update to time per update. Yeah, that's working. Time per update equals same divided by 60. Let's keep it at the 60 updates per second. And of course we need the same here. Need a long private long last update. And in this bracket we simply add a new if statement. If system.nanotime minus last update is more or equal to time per update. Then we update game. And since we don't have anything to update, we're just gonna make a simple void update game. And let's just add something very simple in this method, such as .out.println. Why did everything turn gray? Makes no sense. System.out.println game updated. Game updated. And of course we can also check how many times we update the game per second as we do for the frames per second. And we do that by doing something very similar like we did in here with this call FPS method. So we need two variables, one to store the frames and also one to store the last time we checked. So up here we go and add private int updates, we're gonna call it, and then private long last time updates per second. Yeah, that's good enough. And then we go in here, we can make a method called call UPS. No fancy name, just so we know what it does. Private void call UPS. And in here we go, nope, not there, but yeah, we go in here. If system dot current time is minus last time UPS is more or equal to 1 second. Now we're dealing with time millis, and here we're dealing with nanotime. And if that is true, we system dot out print line. Then we want to say UPS is plus updates. And we also reset updates to 0. And last time UPS equals system.current time is. Yeah. But I'm pretty sure we're missing one part. We're doing that in here. We can go actually, yeah, let's put it in here. Updates plus plus, so every time we update the game, we add 1. And we also need to add one more line, which is last update equals system dot nanotime. It's the same as before with the frames per second. Yeah, so this should work. Let's try it out. See what we got. Oh, that's a lot of spam. Game updated. We're gonna remove that for now. We know it works. Let's run it again and let's see what we got. We got a 60 updates per second and 120 frames per second. And it looks very stable right now. Oh, we're 121. But that's okay for this very simple game loop. So even if we resize it to very small, you see we had a, let's close this and let's check. We had a drop here somewhere here. Updates per second 60. We had a frame drop when we did that, but the update per second stayed the same. So even if we get some sort of lag because, I don't know, a pop-up or resizing the window, but we're not going to be able to do that later. We're going to deny access to do it or remove the ability to do so. But even if we have a frame drop, we have a stable updates per second, and that is what we were looking for. Perfect. And the next thing for this game loop is a thread. What is a thread? Well, a thread can be created, and this would allow us to run a different task at the same time without interrupting anything else. If we wouldn't use any extra threads, besides the one that we are using by default while playing, we would run into a lot of lag and the game might freeze a lot. Which is hard to understand why it happens sometimes, but it's usually because we run everything on the same thread, and that creates something called traffic jam, in lack of better words. So we need to add up more car lanes, create more threads to allow different tasks to be run without interrupting the main rendering thread, for example. A very common issue you would run into if you were to add audio into the game. As soon as the audio clips get played, everything else will pause and wait for it to be done playing. The rendering as well as the updates would stop. That would be a terrible game, but if you were able to create a thread and play that audio in that new thread, the game would be able to run like normal and the audio would be played at the same time. So let's add a thread. There's a few different ways we can implement a thread, but the simplest way is to add implements runnable. And runnable is just the run part of the thread that gets run whenever you start the thread. We need a thread as well. Private thread game thread. And it's currently in red because we implemented runnable, but we have not added the runnable macro. In here we type or we code whatever task we want it to be run in the thread. So this is the section of the thread that gets where we put the code, what we want it to do, what the thread is supposed to do. There is another way of creating a thread that I can show, but we won't use it. And that would be just to thread t equals new thread. And that's how it looks when you start a new thread. But this thread is now empty. We need a new runnable. I'm not gonna type everything. I'm just gonna make it quick. It looks a bit different how you initiate usually. But now this thread has a run method, but it's still empty. So we would put the game loop here, for example. But we're not gonna add it like this. We're gonna add it a little bit different. So we have the game thread, and this is where everything starts, but we can remove loop game and make a method called start. We're not going to use that, but we can use a new one called start. And here we will initiate our game thread. So game thread equals new thread. But we need some sort of runnable here. But this class implements a runnable and the method is already here. All we need to do is go this. So we don't have to add a new one. So it will look for the code here or whatever we need to run here. And start, and also, of course, we need to say game thread.start. I don't know why this is jumping down. It looks stupid. Save it. All right, good. So now we start. We have a method called start, goes in here and initiates the thread, whatever needs to be run, and then we start it. And in here, we will put our game loop. So we will clean it up a little bit. So to clean up the entire game loop we have, let's go through what we have. We have render and we have update. Currently update is empty, but that's what we have. We also have way of checking FPS and UPS. So let's start with adding the render portion of the game loop. And we have here, can remove this one or copy it and place it here. So there we go. And we also need to have while true. And it needs to be in here. So here is our render. And we can actually move these two, time per frame, last frame. We can remove them and put them in here, in this run method. We can actually remove that one and that one. And why are you red? Initiate variable, yeah, obviously. And then we have this time per frame. And down here, time per frame. And we also call equals system.nanotime. Last frame, system time, there we go. Yes, perfect. And now let's add the update per second. We go and remove that or copy it and place it down here. That looks good. Update, call update per second. Yeah, we can remove that for now actually. And since they're only, yeah, we can remove that, or we can. And if we try it now, it works. Perfect. So the thread is working. And if we forgot to, for example, to start the thread, which is usually something I forget, nothing would happen. So remember, we always need to start the thread if we want to use it. And we can of course remove this part. And we can keep call UPS soon. And down here we can call UPS to check how often we do update per second. And that's the same as well, 60 frames or updates per second. Perfect. The game loop works. And I want to clean up this a little bit more before we continue. And we can do that by saying frames plus plus. And we're gonna move this call FPS into the main loop. So we can actually just remove this, or actually let's copy this. No reason to just remove it completely. Call FPS, and then we have these two variables, remove them as well. All right, so we need somewhere to store it. Int frames equals 0. And we need a long last time check, because we're going to use the same check for both the UPS and frames per second. We can remove that as well. All right, and we also need int update updates. Keep it in the same spirit here. Updates plus. There we go. All right, let's see. What else? All right, and down here we will go if system dot current time is minus last time check more or equal to a second, because we're still using, well, now we're using millis, so we need to check for milliseconds and not nanoseconds like here. And why are you sad? Because it's not initialized. Equals system dot current time is. That's good enough. All right, we can move this actually here so it looks a little bit cleaner. Time per frame. This looks better. That looks good. That looks good. Perfect. And here we will simply call, what should we call it? System.out.println. And here we go, FPS plus frames. Can make one of those. And then UPS plus update. Come on, updates. And then we need to frames equals 0, updates equals 0, and last time check equals system dot current time is. There's no reason to have two checks, one for frames and one for updates, if we check every second for both. So this will check for the stats, this will update, and this will render. And if everything works, it should run as normal. It does. And if you look down here, we have 120 frames per second and 60 updates per second. It works as intended. Perfect. And now to finish off this game loop, we need to add the update parts into this loop as well. So let's go double time per update, just like time per frame. Let's copy this. And let's go 60 and not 120. We need long last update equals system dot nanotime. Yeah. Let's go like that. Looks a little bit better. Let's separate those two. Perfect. Let's keep it like so. All right. And we also need to go up here and remove those two and remove that one. Let's go down and see last update. Yeah, then move it from there and add it in this update part. Last update equals, let's just copy this. I don't want to write. And let's add that at the bottom. There we go. So I think that looks good, but there's one more thing I want to go and change, and it's frames. We're going to make a variable at the top, FPS set, and then of course UPS set. And we go up here, private final int, no, not int, double, we can copy that because we use it twice. FPS set equals to 120, and again UPS set equals 60.0. And if we want to change, instead of going down and looking for the game loop, we can just go up here and set the values that we desire. I would say that this game loop for now is complete and we don't really need to change anything. There will come a time later in the development where we might want to add a function that if the game lags, we can catch up to the time it should be, but isn't at. Because for some reason, if the game lags right now and we miss a few updates, we will be behind a few updates. And there is a way to catch up to where we should be. But nothing we really need to add right now. We might need to add it later. We'll see. Before the end of this episode, let's do a quick recap what we have done. We started out by doing a very simple, if not the simplest, game loop we can possibly do in the Java, which is just repaint, and that's only doable if we're using the Java Swing library with JFrame and JPanel and paint component sort of stuff. That's the only time we can use it, really. And after we did that, we saw that the game could loop, but we had no way of controlling how many times per second we updated the game or redraw the game. So we added a counter to see how many times per second we redraw the game, which about 800 something if I remember correctly, which is very high and completely useless to have it that high. So the next step was to set a limit, 60 frames per second. And after that, we also added updates to the game and what the difference is between frames per second and updates per second. And why we can let the player, if you want to, let the player decide the frames per second. Maybe he has a very good computer and then there can be a much higher frames per second. But why we never want to let the player change the updates per second. And as soon as we're done with both of those and they run independently, one was set at 60 frames per second, 120 frames per second, and the updates were set at 60 frames per second. And after that, we implemented threads, or a thread, the game thread, and what it is, and why we use it. After we added the thread, we also cleaned up the game loop a lot, and it looks much nicer now, and it works just as well, if not better. In the next episode, we will add inputs from the mouse and keyboard, and also game states, I think. We'll see how much time we have. But this is all for this episode. I hope you learned something about game loops, and I really hope to see you in the next episode as well. Until then, have a great day, take care, bye.